Hello everyone, my name is Harsh Sharma and my registration number is 19BCE1464. So let's begin with our 8085 microprocessor. So this is the block diagram of 8085 microprocessor. First we will discuss about the block diagram of 8085 microprocessor. After then we will discuss about the pin diagram. So first of all I want to tell you that 8085 microprocessor is the most commercially used 8-bit microprocessor, and it has three data buses, that is address bus, data bus and control bus. So address bus, as the name suggests, address bus will hold the address of the data. So its size is 16-bit, and that means that there are 16 lines or 16 cables that will take the value 0 and 0 or 1. So we have 16-bit length of the address bus, that is 64 KB of address we will store in 8-bit microprocessor, that is 8085 microprocessor. After then we have data bus. Data bus will carry the data from memory to microprocessor, and its size is 8-bit. And the control bus. So in microprocessor we need to read or write from the microprocessor. So control bus uses to read and write the data in microprocessor, and its size is 8-bit. That's why. And the ALU, that is arithmetic logic unit, its size is 8-bit. That is the heart of the microprocessor. ALU is the heart of the microprocessor, and ALU stands for arithmetic logic unit. Arithmetic means add, subtract, multiply and divide operations, and logic means XOR or operations. So the size of ALU is 8-bit. That's why the size of whole microprocessor is known as 8-bit. That's why it's also known as 8-bit microprocessor. So in microprocessor we discuss about the flow of data in microprocessor. So let's discuss about the flow of data. Let's start with PC, that is program counter. So the use of PC, that is program counter, is to hold the address of the next instruction to be done. It will not store the address of the current instruction. The current will be going on, but it will store the next instruction. For example, if we have a series of instruction, that is 1 2 3 4 5 6 7 8. So if 5 is going on in the microprocessor, then it will hold the address of the 6th instruction. So if we define the PC as a formal language, then formal definition, then the definition of PC is that it will hold the address of the next instruction to be done in microprocessor. After then we have increment, and also the size of the PC is 16-bit, and because the address bus size is 16-bit in 8085 microprocessor, that's why the address of the PC is 16-bit. After then we have increment, decrement. Increment and decrement registers main use is to increment and decrement the value of PC. So that's why its size is also 16-bit. After then we have two address buffers, that why we have two address buffers? Because we have the one address buffer as a size of 8-bit, and we have the size of the address as 16-bit. That's why we have two address buffers. The first 8-bit will be stored over here, and the second 8-bit will be stored over here. Now the address will be the data will be fetched from the memory, then the data will be from here, travel from here to here, that is instruction register. So this is the very popular question in microprocessor, that the data that is fetched from the memory will be stored first where. So its answer is instruction register. So the data that is fetched from the memory will be stored in instruction register. The data will be stored in instruction register. After then the data will be in any language like English, Hindi, French, any language. That the data will be converted into 1 0, that is binary form, with the use of instruction decoder. So the instruction decoder main work is to convert the human readable language into machine language. Now when the data will be converted to 0 and 1, that is binary form, then the timing and control circuit will work. It will send the signal to whole microprocessor, that what it have to do. When the uh, signal will be sent it to whole microprocessor, then after then the first operand, that is the first operand will be stored in accumulator and the second will be stored in temporary register. And the size of the instruction register is 8-bit, instruction decoder is also 8-bit. So accumulator, the size of the accumulator is 8-bit, and the data, that is the first operand that came from the accumulator. So if we have to add 2 plus 5. So one more thing is that microprocessor will only understand the assembly language. So assembly language are move ab, like that language, that add ab, sub ab, those languages will be understood by a microprocessor. If we give the instruction like add ab, or we give data directly like add 2 5. So if we want to add 2 plus 5, we will give the instruction as add 2 5. So if we have 2 plus 5, then the first operand, that is 2, will be stored in accumulator, and the second operand, that is 5, will be stored in temporary register. So it is also a very popular question, that the first operand will came from accumulator. So now the 2 and 5 will be sent it to ALU, that is the instruction will be sent it to ALU. Now ALU does the arithmetic and logic task, and it will add 2 plus 5, and its output will be stored in accumulator. Now this is also an important question, that the output of the ALU will be stored where, and its answer is accumulator. So accumulator will be stored output of the ALU. So after then we have flags. Flags are also known as status registers. There are 5 types of flags: 0, carry, auxiliary carry, sum, and parity. So the flags will only store the status of the output, it will not store the output. For example, if we want to add 7 and 6, then we have 7 plus 6 as 13, and we have one carry. That carry will be stored by flags. So the flag will be have two types, flip and flop. Flip means 0, flop means 1. So it will only store 1 and 0. Now we have general purpose registers, that is WZ, BC, DE, HL, and these all general purpose registers are friend of the developer. They use the assembly language to access those registers. I told you about assembly language, that move ab, add ab, and sub ab, multiply ab, like that of the language will be read by the microprocessor. So the size of the general purpose register, that is W, Z, B, C, D, E, H, L, are 8-bit, but we can also use them as 16-bit by combining them as horizontally. We cannot combine them vertically, we only combine them as horizontally. Like WZ will be combined, BC will be combined, DE will be combined, HL will be combined. So by this way we can use them as a 16-bit register. So we have discussed about the whole thing, but only stack pointer, interrupt control, and serial IO will be left. So first of all we will discuss about the SP, that is stack pointer. So stack pointer will work on the LIFO technique, that is last in first out. So LIFO technique, for example, if we have a container, that is a biscuit container, then if we want to add if we want to put the biscuit in that box, then we will put one by one, and the last biscuit that we have put on, we will take that biscuit at the first. So the same way SP will work. We will put the data in the address of the data in a box, that is in a in a chip, or we can say that in a memory. And after then, if we want, it will if we want to take out the data, then the data that we will be putting at the last will be taken first. So if any interrupt will be happen in the microprocessor, that is handled by the interrupt controller. Interrupt control will work on the two techniques, that is INTR and INTA. INTR stands for interrupt request, INTA stands for interrupt acknowledgement. These two pin INTR and INTA, we will be discuss about these in pin diagram of the 8085 microprocessor. So serial IO, as the name suggests, IO stands for input and output. Serial IO will be work on two pin, that is SID and SOD. SID stands for serial input data, SOD stands for serial output data. So we have discussed about the block diagram of 8085 microprocessor and the flow of data in 8085 microprocessor. Let's recap the whole process. After then we will discuss about the pin diagram of 8085 microprocessor. So the size of PC is 16-bit, and it holds the instruction, that is address of the next instruction. Increment, decrement, it will increment and decrement the value of PC. The address will be sent it to, we have two types of address buffer, and the address will be sent it to here. After then the data will be fetched from the memory to instruction register. Instruction register will host the data that is fetched from the memory. After then the instruction decoder will convert that data in machine language or in binary language. After then the timing and control will send the signal to microprocessor that what it have to do. After then the accumulator will store the first operand of the data, and the temporary register will store the second operand of the instruction. Then that instruction will be sent it to ALU, and ALU does the arithmetic and logic task, and it will after the after that after the then the output will be stored into accumulator. Now the output will be stored to accumulator. Now we have flags. There are 5 types of flags, and it will store the output status of the output. So after we have general purpose register, there are their size is 8-bit, and these are the friends of the micro developer, and they use the assembly language to access them. After then we have stack pointer. Stack pointer is also used in to store the address, and that's why its size is also 16-bit. And stack pointer will work on the LIFO technique, that is last in first out. After then we have interrupt controller. INTR and INTA. It will work on INTR and INTA. INTR stands for interrupt request, INTA stands for interrupt acknowledgement. So now we have serial IO, that is serial input output. So SID stands for serial input data, and SOD stands for serial output data. It works on SID and SOD, the, two pins. Now we will discuss about this is the whole working process of the 8085 microprocessor, and the data flow of the data flow in 8085 microprocessor. We left with now we will discuss about the pin diagram of 8085 microprocessor. So this is the pin diagram of 8085 microprocessor. There are 40 pins, 20 left side and 20 right side. So first of all, we will discuss about the VCC. VCC is VCC is the pin from where we can give the voltage to the microprocessor, that is plus 5 volt. And then we have VSS, that is ground for grounding the microprocessor. We use VSS pin, that is 20 number pin. And now we will discuss about these 12 to 19 pins. So AD0, AD1, AD2, AD3, AD4, AD5, AD6 and AD7. These all are address and data buses. Like we are having 8 data bus, so there are 0 to 7, 8 data bus, and these are multiplexed with address buses. So we know that that in microprocessor there are the length of the address bus is 16 bit and the length of database is 8 bit. So address bus and data bus from 12 to 19 are multiplexing. So they are multiplexing, and rest of them, the 8 address buses are 12 to 19, and 8 address buses are from 21 to 28. So there are total 16. 16 the length of the data address bus is 16. That's why there are 16 address buses. 8 are multiplexed with data bus. So this is a common question. This is a question in for 8085 microprocessor, that how many address buses are multiplexed with data bus. So there the answer is 8. So now let us discuss about SID and SOD. SID stands for serial input data. So when we give the input to the microprocessor, then the input will be taken serial wise, like 0, 1, 2, 3. The same way when we take out the data from the microprocessor, then the data will be taken out serially. That is why SOD from SOD, and the full form of SOD is serial output data. The data will become serial wise, one by one. Now let us discuss about the NTR and INTA. There are 5 types of INTR, that is request controller, that is trap, RST 7.5, RST 6.5, RST 5.5, and INTR. So for interrupt control, there are 5 types of controller, and if we give them priority, then the trap will have the highest priority, and their priority will decrease. Like first of all, we have trap at highest priority, after then RST 7.5, RST 6.5, RST 5.5, and after then INTR will have the smallest priority, and trap will have highest priority. Now if we know that the interrupt occur in the microprocessor, and that is acknowledged by INTA, that is INTA interrupt acknowledgement. So when any interrupt will happen, then the microprocessor will send the acknowledgement through this pin, that is 11 number pin. Okay, now let us discuss about X1 and X2. So the main use of X1 and X2 is it maintain the frequency of clock. uh, it will maintain the frequency of clock, or we can say it will maintain the frequency of the microprocessor. So if we are talking about the clock, then let's see the 37 number pin, that is CLK. So the use of clock is it will if we are giving some work to the microprocessor, then the uh, clock will record the time, like how much time the code will take to work. For example, if we are doing a coding in C++, and if the and we are giving the loop for loop, and the loop is infinite, then the clock, this CLK will work and send the acknowledgement to the sender that the code execution time is too much. So that is done by CLK. Okay, now we have discussed about only reset out, and reset out will be left to the left hand side. So let's discuss about the reset out. We'll discussing about the reset out, we will discuss about the reset in also. So reset in and reset out, we have seen that stack pointer will stack uh, for example, if program counter is using the address from the array. For example, they are using the addresses from the array. So we are taking the input one by one. We are like it array, if we are at 5 and we want to reset it, then it will come to 0. So to make that program counter to reset, to start it with initial value, then we use the reset in in pin, that is 36 number pin, and the use of reset out is that it will tell the microprocessor that reset happened in the microprocessor. So this is the main use of reset out and reset in. Now we will discuss about S1 and S0. For discussing S1 and S0, we will see this table, and we'll discussing about S1 and S0. We will also discuss about IOM, VPP, RD, and WR. IOM is input output, and RD is reading, or WR is writing. So if our S1 and S0 value is 0 1 and IOM value is 0, that means memory write, we are writing in the memory. In the same way, if IOM value is 0 and S1 value is 1 and S0 value is 0, we are reading from the memory. In the same way, IO, that is input output, input write and input read, will work in the same way. So we have discussed about the S1, S0, the RD, reading and writing, and IOM and VPP. Now we are left with HLDA, that is HLDA and HOLD, and uh, I think we are left with HOLD and HLD only, and ready. Okay. So first we will discuss about the ready. So the ready, that is 35 pin. It will tell the microprocessor. It will tell that the microprocessor is ready to do the work or not. Like all pin are at their same at its right position, and they are working rightly. That is acknowledgement by ready, that is 35 number pin. Now hold and HLDA. So hold, okay, if you are having too many videos in a folder, and you selecting the whole videos and tapping the enter button to play all videos at a single time, then you know that there is that that will the time will be out, and that will be provided by the clock signal. That time is out. For hold and HLDA, for example, the microprocessor is doing the work 2 plus 5, that is 7, and if we are giving the instruction will the microprocessor is doing its own work initially. So if it is doing the work 5 plus 2, and we will give another instruction to the microprocessor to do that 7 plus 2. So microprocessor will hold that, we are giving that input, the microprocessor hold that input, and the acknowledgement will be given by 38 bit, that is HLDA. That microprocessor send the acknowledgement to the developer, or to the designer, that the microprocessor is on hold, it is doing some work already, so you can hold for some time, after then it will do its own work. So this is the pin diagram of 8085 microprocessor, and I think we have discussed everything. So this is a working process and block diagram and pin diagram of 8085 microprocessor. uh, Thank you all.